Hello everyone. Today we are going to see how we can design a chat system like Slack or Microsoft Teams or Discord. This is pretty adjacent to designing a chat system like WhatsApp or WeChat, and you can just like find lots of such videos if you look up for it. Um, this is pretty similar, but there will be like some minor nuances, as we add more pieces like workspaces and whatnot. So we'll see how we can design a system like that. So at the beginning of interview, this is what you'll be given. So this is what we call the functional requirements or product requirements. So let's go over this one. So users can join workspaces. Good. So we have workspaces and users have access to channels inside workspaces. Users can send messages in channels. Users can send one-on-one messages. Users receive messages without having to refresh app. So it's pretty clear. And you can ask any clarifying questions if you want. For example, you can say, hey, can a user send DMs to more than one people? And they might say, no, let's just like limit it to only one-on-one messages. That's fine. You can ask other further clarifying questions like, hey, can a message contain media? They might say, no, let's just like keep it plain text for now. So we can add that. So let's just say messages contain only plain text. That's good. Um, so we have a clear finalized functional requirements, and then we can move on to non-functional or engineering requirements. So let's just get into it, right? So non-functional engineering requirements, and here I'll actually share a mnemonic that I use for my interviews and for my coaching. So and actually this is a coincidence. So I use the mnemonic called Slack, SLAC, and you can actually use that. So S for scalability. You can always ask these questions. Hey, what is the scale of the system? And I might say something like 10 million concurrent users. It's good. That actually tells you how big the system is going to be and what are the pieces you need to consider for that. And then L stands for latency. You can ask like, okay, what latency are we considering? Or most interviewers, they'll actually want you to have some opinions. So in this case, I'd say, propose something like, okay, we want to like have something around 200 to 300 milliseconds latency. And they might ask you why. You can say, that actually gives a near real time feeling, and that's acceptable. And then A and C. A stands for availability and C stands for consistency. So in most of the apps, you'll have to like choose one or the other, or at least like for a particular portion of the apps. Um, so you can say for this Slack or like Teams based system, you want it to be highly available, and in some cases it's okay to have a message delivered like maybe say a minute or two late, and that's totally fine. It's not like the end of the world. So you can say availability over consistency, and that's fine for at least like the message deliverability. um, and and then we have teams here. So T stands for throughput. I mean, we know that it's scalable, but what sort of throughput are we thinking? So you can say, you can ask this question: how many messages are going to be sent in this system? And they might say something like maybe a billion messages. So that's going to be our throughput, 1 billion messages per day. And then you can translate it roughly to like 10k messages per second. And this is a work. I mean, Slack, Teams are mostly like workplace chat system, so it's not always going to be like equally distributed. So sometimes during peak hours you may have two or three times the messages, so that you can like talk about that. And above all, there is one more thing you have to ask. This is a chat system, and it's applicable for most of the uh, systems that you'll be designing, but at least like for chat system you'll have to like bring this up, durability. We don't want our system to lose any particular messages. It can, so here's the difference is consistency. Yeah, it can be delivered like a minute or two late, but we don't ever want to lose the messages. So once you share this, you can get alignment with your interviewer, and once they say they are game, then you can like simply move on to the next phase. For the next phase, you can high level point at some entities or data model. Don't spend too much time on it. You just like, all you have to do is just say, hey, these are my high level entities, and you don't have to like go deep into every single fields. I see this mistake being done by lots of interviewers, so just don't do that. So let's go. For entities, you can just like go from here. So we say we need user, so let's talk about user. So user is an entity. There is going to be workspace, and there'll be channels. Okay, that's good. Channel is a entity. And yeah, you can, if you want, you can just like say channel will have details of workspace, because of course channel belongs to a particular workspace. And then user can join workspaces, so then we can say something like user workspace membership. We don't have a separate membership for channels for now. Like we can, you can ask this clarifying questions, but for this system we can just like say user has access to all of the channels that they are part of. And then we have messages. So here we have both one-on-one messages and channel messages. So you have to ask yourself, do you want two different entities, or you want like one entity? um, it's You have to make the right choice. Or you can say I'm gonna like choose something, and then maybe like I'm going to like fix it if it doesn't feel right. So for this case, we can go with two separate entities. So one called channel messages, and the other one called DM messages. And so here they might ask why, and you just have to justify it. You don't have to go deep unless they ask, but there are chances that they might ask, and then you can say something like, okay, channel messages will have this data model, right? Say, sender ID, this would be the user information, and then channel ID, and then content and timestamp. And for DM messages, can pretty much copy all of it, but the channel ID is not applicable here. So you'll have to figure out some other way to kind of like group these messages. So one thing you can do is, so this is one-on-one messages, we confirm that. So in that case, you can say, okay, I'm going to lock in something like this: user A ID and user B ID. So for any two users, you will sort them, and in the lexical order you will just like use that as an ID. And if they say you want to like add more people, then we can like figure out, but for now we can just like say this is how we are going to separate. So that way every single DM will be like under this particular ID, and you can use it to look up the messages. So I think we are good. And then we can directly move on to design, system design. I see a lot of people talking about like a back on the envelope calculation, and that's fine in some cases, but I have seen people spend a lot of time in modeling the data and just like doing a lot of calculations just to say that, hey, yeah, we need like terabytes of space or petabytes of space. Yes, we all know that. I mean, this is a big system, so we just know that we are just going to like need a lot of servers and a lot of space. So you don't have to like spend too much time on it unless it's really really necessary. Okay, so at this point, you can ask your interviewer if they have any questions, And if they have any questions, you can clarify. If not, simply like move on to the high level system design. Just like mentioned that you are going to like, just like start with the high level, and then you can go deeper, in the next phase. Okay. So here we are like all professionals, so we know that is a chat system. So you can just like say that, okay, from the very beginning we are just going to assume that WebSockets is like the right way of like, communication model. So because it's going to be bidirectional between client and and the server, so you can just like say you are choosing WebSockets as like the right protocol here, and that's totally fine. Okay, so let's start the system. So at the beginning you will have a client, and the client can be any app, iOS, Android, it can be even desktop app. That's totally fine. um, and let's move on. So okay, so you have a client, and then you will have this client talk to your system, and the entry point would be, we can just like, for this case we'll just like say a load balancer at the beginning. So this load balancer, when the very first time the user connects, this load balancer will be the first person they'll talk to, and then this will connect the user with a server. So we will add a simple service called chat service here, and this load balancer will take you to a particular chat service that's available. And once it's connected, initially you will be using like a simple HTTP protocol, but once it's connected you can upgrade to WebSocket. So after that you will be directly talking to this chat service. You don't really need to go through the load balancer unless the chat service crashes or you disconnect. So we can just call it out. And so once that's done, so this is going to be like bidirectional. So you will have like connection, persistent connection with this chat service, and so through this you will be like sending all the messages. And it's also helpful to identify some of the messaging, API. But since it's WebSocket, there is like really no agreed upon protocol. So you can just like simply say, hey, I'm just gonna be like, you can just like simply say, you'll be using notations like send message, receive message, add channel, look up for channel. You can like do whatever you want. So all we have to like do is like just like clearly talk it out to the interviewer, and then they'll be fine with that. Okay, so we have a chat service. So once the client is connected to the chat service, then you can like send the messages to the chat service. And so what will this chat service do? So we can quickly mention some of the responsibilities for the chat service. So first, it will receive the messages that you send, the client sends to the service, and then it would first persist the message. Okay, because we want to persist the message. And then it would manage all the users uh, who's connected to this system. So we can say that it handles the WebSockets. So WebSocket management, and then it will actually, I should like add this one above. So persist the message, and we'll say it also forwards the message or relays the message. Okay. And then it will have more responsibilities, and we can like add as we go. So we'll just like, start with this. So okay, so the message first comes, and we are persisting the message, and in order to persist the message we need a DB. So we'll just like add a DB here. Okay, DB, good. And chat service directly talks to the DB. That's good, and it's not a bidirectional here, so we'll just like, so okay. And so how does it look here? So first the client sent a message, and so it will say a message comes here. So it will just like, create the channel messages and DM messages table here, and it will just like add the user information, who is sending, and the message information here, and that's good enough. Okay, so for now, so when the user first send the message, so it will just do some basic authentication, and then after that, if it's a DM message, It would just like say, hey, this is the user ID, this is the recipient, sender or recipient, and then it would like sort it, it would identify the ID, it would insert it, it would add all the other details, and then once it's done, it would like acknowledge the user that the message is received. And if it's a channel message, then it would do the same thing, but just like, a small variation in like what it's persisting. That's good. So now the next portion. So it wants to, now we wanted the service to forward the message. So here's where it gets tricky. So let's start with a simple case, right? So you have a DM message. So the chat service receives the message, persists it, and it knows who the recipient is. So then it can simply push the message directly. So how would it do that? So here, in a simple system, we can just like assume that we have only one service, and the service actually has all of the clients connected to it. But in reality, the scale at which we talked, it's not going to be happening. Say, one service like, handles like hundreds of thousands of um, WebSockets in one concurrently. The numbers can vary. In real life, WhatsApp has like served up to million user, but we'll just like say one server can handle like up to like several tens of thousands or even say hundreds of thousands of like clients. But even that means we might need like thousands of servers, right? So it needs to push the message to the sender. So how can we do that? So we can do this. Let's add like a pub sub here. Okay. So we can do a Redis pub sub or like, any other pub sub solution would be fine. So we'll just like add, sorry. So here we have a pub sub. Give me 1 second. I'm just going to move all of these things down. Okay. Now we got some space. Sorry about that. Okay. So now we add a pub sub system here. Okay. And the chat service, when it wants to forward the message, what it would do is it would put the message in the pub-sub. So let's say the topic here is like the user ID. Okay, so it knows who the recipient is, and it would just say, hey, here's the message for this particular user. So under this user ID, it would send the message. And this pub-sub would identify the right chat service at which the user is connected and would push the message. So now it means a few things. First one, how does this pub-sub know where the user is like connected to, right? So how do we do that? So we need to add something here. So just let's say whenever the chat service gets a user connected to it, it would subscribe to the pub-sub under the user ID. So we'll just like say subscribes to the user ID. So that way, when the chat service posts the message under the particular user ID, the pub-sub system would know exactly where to go, right? So that is if the user is online. If the user is not online, then what we can do is there are two possible options here. We can just simply say, I'm going to like create a notifier system, and this notifier would just push the messages to the user. So a notifier, we don't have to go super deep. The other option that you can suggest is you can have an inbox sort of data model for the user, and you can say, I'm just going to like post the message to the inbox. So whenever the user comes online, they would just like query the inbox and say, hey, I want to collect all the messages that I've got when I was offline. So you can go with either option and both are fine, but you just have to talk about the trade-offs. In one-on-one case, I think it's totally fine. You can just like say I'm going to like suggest an inbox, and that's totally okay. Um, and So yeah, so this is good for the message. So when the message is posted under the user ID, the PubSub would notify the right service, and that service would actually take the message, and it would actually have an internal map where it says this user ID, because it manages the WebSockets, right? So it knows exactly which WebSocket the user is connected to, and it would just like push the message to the client, and then the user will get it. So that's good. Now, if it's a non-DM message, which means if it's a channel message, how are we going to handle it? So we can pretty much go with the flow of like how we handle the DM message, and we may have to make some changes. Let's look at that. So the user sends a message to the chat service. The chat service goes and passes the message to the DB. So how does it do? So this is the sender ID, this is the channel ID. It may first want to validate if this user has access to the channel ID and whatnot, but that's not important here. So once the message is like persisted, now it wants to push the message to all the users, right? So how would it do? There are two possible options here. One is we have user workspace membership, right? So let's say the table is the data is here. Okay, so here it would just like have all the information here. So workspace ID and user ID. Okay, so let's say this is partition key, and so you can just like, and it's indexed, so you can just like say, hey, give me all the users of this workspace, and you can also like have the workspace ID here. It's fine, you don't have to it's okay to be denormalized. You will just like say, hey, give me all the users that are like part of this workspace. You get a list of all the users, and then you can do a pub sub for all of the users. So that's one possibility. The second possibility is you can simply post the message under the workspace ID. But if you are doing that, then we'll just like have to also say the the chat service also subscribes to the workspace ID, and it will always also maintains a map of workspace and the users. So it would say internally something like this: workspace 1, user 10, user 22, something like that, and workspace 2, user 1, user 2, and dot dot dot. So when we post the message in the PubSub under a particular workspace ID, it would it would have subscribed to the workspace ID, and when it gets the message, it would look up for that workspace, and it would like have a list of all the users, and it would just like send the messages to all the users that are like connected to that particular service. Both models have its own pros and cons. For example, if you say like, okay, you want to go to the model where you just like look up all the user IDs and you do a pub sub for all the user IDs, and so the chat services directly would just like get the messages for like all the users it's connected to, and it can like simply push. It doesn't really have to like maintain the map. But there's a lot of load on the sender chat service. In the other model, it would just publish the message only once under the workspace ID and in the PubSub, and the chat service, then the receiving chat service would do a lot of management. So it knows exactly who the users are, the target users are, and then it would like push all the messages. So there is always like pros and cons, and you just like have to like clearly talk about like, okay, what's there and what's not there. In both the cases you will have to like definitely mention this one. So what if a user is not connected? So if the user is not connected, in your first model where you just like have a list of all the users, you can post and you can notify. So that way you kind of like do both. So even if they are not online, you will make sure that they get the messages through push notification. But in the second case, you don't really get to do that, because you just like send the messages, and if the user is like not at all like connected to any of the chat service, then they do not get the messages. So you'll have to call it out. And then if you want to go with that solution, then you will have to like say, okay, I'm going to add something else, so we make sure that the user gets the messages. In some systems like WhatsApp, you can say, hey, I'm going to create inbox for all of the users in the particular channel, and I will make sure that the data gets added to that DB under that particular inbox, so they never lose the messages. You can say that. But here the trick piece is, in systems like Slack and Microsoft Teams, you have you can have up to several thousands of users in a channel. And so it's not that easy to write these messages, because if it's under 100 like WhatsApp, it supports more than 100 people right now, but before, like at the beginning, it supported only up to 100 people. You can create a transaction and you can write all of these messages to the DB directly, and since it's transaction, it's much easier. But for thousands of users, you cannot scale a transaction, so you'll have to come up with a different model, right? So you want to like talk about that as well. So we will cover all that. So at this point, we can just like see if we have covered all the basics. So we can say user can join workspaces. That's pretty easy. If the user joins, we can have for at this point, you can create a separate service, but it's fine. You can say the chat service directly kind of gets connected. It just like adds an entry to the user workspace membership. So easy. User can access to channels. So it can like say you can add a new endpoint or like the messaging pattern. It says get channels, and your system would just like return all the channels to the user by the workspace ID. So it will look up for all the workspaces that user is part of, and then it will just like look up for all the channels that the workspaces have, and then just like returns the data to the users. And then yeah, sending messages one-on-one, sending messages channel, user receiving messages, we covered all of that, so that's good. So now let us get into some deep dives, and in the deep dives we can see where things can go wrong and how we can fix it. When it comes to deep dive, most interviewers would expect you to identify some problematic areas where things can fail, where things can go wrong, and would expect you to drive the conversations. But in some interviews, if you're like a junior engineer, or sometimes interviewers want to actually focus on a particular piece, so then in that case, they would ask you questions. Hey, I wanna like know how this is gonna be like handled. How are you gonna like handle this particular situation? They'll throw a situation at you, and then they'll expect you to like solve for it. So let's pick the first scenario, right? So now you have to drive conversations, identifying bottlenecks and points of failures. Okay, so let's see. This is where I would use the non-functional or the engineering requirements. It can tell you where things can go wrong. This is the map kind of like thing. So first, we want the systems to be scalable, and we said like we can have up to 10 million concurrent users. So can our system handle it? So you can have 10 million clients, and you can have multiple load balancers. And these clients, when they first talk, they'll talk to the load balancer, and then the load balancer will connect to the chat service. So we can simply say, how's the routing done? You can say you have a consistency hashing, where a particular user ID is routed to a particular chat service. You can say that. Do not get yourself like cornered by saying that you are gonna like do this by like workspace, because a user can be part of like multiple workspace. So you can simply say, hey, my load balancer actually maintains a list of chat service. So it maintains a map of chat service and connections. So this is a very simple one. So it maintains a map of all the available chat services and how many connections it has, and you can use it to make an educated guess on like how it wants to route the system. And the chat services would send signal once in a while, or whenever a person leaves, it would just like update this message, so it can always have an updated list of how many chat services are there and how many connections are active. And if a service doesn't send a message, then it can like check if the service is still active, and it can use it to like update the data, and it can use it to route it correctly. So scalability, not really a problem when it comes to this. And so we also can limit the number of concurrent clients are connected to a chat service. So there is a physical limit of how many you can handle, but we can just like say for now, say up to 100,000 clients can be connected to a chat service, and that's okay. And how would that affect the further step? So during peak hours, you have hundreds of thousands of clients connected. So we say just 100,000 clients connected, and they can be sending tons of messages. And you first want to persist the message, right? So there could be a lot of messages coming in, but when you talk to DB, the DB has like a limited connection pool workers. So that is a problem area. So what if the DB is slow? How do you handle that? So that is a problem area, you can say. And so one possible solution is you can always like add a separate queue system here. So let's just say I add a queue. So we can say I'm using Kafka here, and all I'm doing is when I get a message, I would just validate the message, and then I would write it to the Kafka. So I don't have to rely on the DB being in the same speed. So two systems, different speeds. Now Kafka actually can help us. So it really is not a problem. Kafka can directly not talk to the DB. So we'll just like say, uh, you have a worker here. Oops, sorry about that. We'll just move this down. Okay. So this is an async worker. It just reads from Kafka, and we can call it a persistent worker, and then it just like writes to DB. So this way we are like decoupling the system, and so we don't have to worry when the chat service gets overloaded. So chat service is like simply a producer, it can keep up with it, and Kafka is durable, and that also covers the other problem we have. So what if chat service crashes? We don't really have to worry. uh, but chat service will not like lose the message. If it loses the message, then we don't send an acknowledgement. We write the message to Kafka, and once Kafka sends an acknowledgement, then we send the message to the client saying, hey, yes, we received your messages, and that's good enough for now. And if the message acknowledgement doesn't go through, then the client would like send the messages again and again until it gets an acknowledgement. So that is not a problem. Okay, cool. So where else things can go wrong? So let's talk about this one, right? So we persist the message. That's good. So we have added the Kafka, and then the worker will consume from Kafka and write to DB. So that part is done. Now where can things go wrong? Forwards and relays. So here we have just added one more layer to the system. So the chat service writes to Kafka, So now, do we wanted to forward the message immediately after writing to Kafka, or should we wait until the message is persisted? So, it's a very interesting thing. So, you have to talk about the trade offs. So, what would happen if the message is like forwarded right away, right? I mean, you have the message clearly in the Kafka, so written, you can send the message to the users, right? But here's the interesting piece. So previously we said like we'd persist the message, and when we persist the message we'll have an ID, and we can use the ID to send the message here. So that way it's just like, the receiving service would just like look up the message and it would like forward to everyone. But now we may have not persisted the message. So how do we want to handle that? It's a very interesting problem. You may want to think about it for a minute. If you want, like, pause the video and think about it. But if you are like interested, then here's a possible solution. There are again, like, just like any solution, there are like tons of ways you can go about it, but this is a very good interesting solution. So when you write to Kafka, right, you don't have an ID yet because we get the ID only from the DB. So we first need something that we can use as an identifier. So here you can use something like a external ID generated system, something like, a Snowflake system. So we'll just like say here Snowflake ID generator, and the chat service would just like get the ID and use the ID to write to Kafka. And when the worker writes to DB, it uses the same ID, and so if we can use that ID would be unique here. So we'll just say for every message we'll have ID, and this is a Snowflake ID. And this is applicable for both DM and also for the channel messages. So this with this ID you can actually look up the message. But okay, so we got the ID and we are using the ID, but when the chat service, the recipient chat service gets the ID, it would look up the DB, right? But the DB may not really have the message yet. So what are we going to do about it? So here, one solution is you can add a cache system. So how it works is, so here we just like add a Redis cache, and so the chat service gets the ID, writes to the Redis, and the Redis would have something like this: ID, content, and similarly pretty much all the structure like here. So this is, you can say, it's very similar to the channel messages or DM messages, and it keeps the ID here temporarily. You can even like set like a TTL for some time, or you can like add a like further system where it just like, the worker, once it's written, you can like, ask the Redis to remove it. It's really like, you can, there are like many ways to go about it. So with this, what happens is when the message comes to the chat service, it gets the ID, and this ID can be per channel, so it's not a big problem. So that way, like, it's just like we want the messages to be sortable, because there could be like tons of messages coming from various clients at the same time, and we need a way to sortable. So Snowflake ID actually helps you that, and you write it to Redis and then you write it to Kafka. You write it to Redis and then write to Kafka. So after writing to Kafka, you send the acknowledgement. Okay, and then the worker would pick up from Kafka, it write to DB. So when a user goes to a particular channel, you know it would send a message like, hey, get all the messages from a particular channel. Here's how the system would do: it would go get all the messages in the DB, and it also knows that the DB may not have all of the messages yet. So it would just like pick up some of the top messages from the Redis that may have not have been persisted, and it would just like combine both and returns it to the client. So this is a good system where we don't really lose any messages. um and yeah, and then what other things that can go wrong, you can like talk about it. So availability, consistency, that's really not a big problem. We have just like talked about it. So even if the message is particularly like for a particular user, if it's not delivered, that is okay. You can just say my client would just send, for every 2 minutes it would just like send a query to, hey, these are all the messages that I've received in the last few minutes, and it can send the IDs. And if there are messages that are lost, you can like use a reconciliation to fix that gap. Okay. uh, Item potency is a big problem. So we just like mentioned that if the acknowledgement is not there, then the client would resend the messages again and again. And many interviewers can actually ask you this question: hey, if my client is not online, or if the network is flaky and if it keeps sending the messages, how do you handle the how do you handle the duplication? You can always just like say item potency key is like very easy. So you'll just like say a client generates a particular key, and it would use the same key to resend the message again and again. So that way the chat service, once it's receives the message, it would actually create, you can also like you can use the same Redis or different Redis, that's fine, but it would just like say, hey, yes, I just processed this message and I have already like put it in Kafka. So when the second or third message comes, before processing, you can look up the Redis and see if I have recently processed the message or if anyone else have recently processed the message. So if that happens, then you can like simply drop it, and the client would just like get like the acknowledgement, or you can send the acknowledgement that like the Kafka already like got the message, because it's possible that the acknowledgement was like just lost by the client. So yeah, I think we have covered pretty much all of it. Yeah, take a look, and if you have any questions, please add a comment. And yeah, thank you. Wish you all the best in your interview.